So good morning, everyone. Okay, so today's date is 14th July 21, and our today's topic is first topic. Today's first topic is Maxwell and Boltzman distribution of molecular speed. Maxwell, Boltzman distribution of molecular speed. Yes. So this is our topic. Now, thing is that we know what are gaseous substance. We know that gaseous substance are having very tiny particles, and they separated from each other by a large empty space. Okay, suppose one gas molecule is present here, another gas molecule is present here. So they are separated by large distance. Okay, and and we know that the particles are continuously moving. As they separated by large distance, the intermolecular force of attraction is negligible, and that's why the particles, okay, the gaseous particles are continuously moving in all the direction. And during their motion, okay, they continuously collide with other particles and also with the walls of the container. Okay, and because of this collision, the speed and the direction of the molecules go on changing continuously. Okay, because of their random motion, because of their random collision with other particles and with the walls of the container, okay, their direction and their speed continuously changing. Okay, so if I consider a given sample of gas, all the molecules which are present in the given sample of gas do not process at the same speed, because as the particles are continuously collide with each other and with the walls of the container, so obviously their speed will be different molecule will contain different speed, because different molecule have different collision. Okay, and the speed of individual molecules are different and distributed over a wide range, because gaseous molecules are separated through a wide range. So obviously distribution of the speed will be separated through a wide range. Okay. And one interesting fact is that if all the particles have same speed initially, suppose initially all the particles have same speed, but due to this molecular collision, they will have different speed. Suppose at the beginning, okay, at the very first moment, they all have same speed, but because of they continuously collide with each other, their speed become different. So it has been showed by a graph. Okay, I'm just going to draw the graph. It has been showed by easily with the help of a graph. Okay, this one, and suppose this one is 0, 1, 2, 4, 6, here 8, 10, 12, and this side suppose 0, 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5. Okay, like this. Now, along the y-axis, okay, along the, x-axis is the molecular speed. X-axis is the molecular speed. X-axis is the molecular speed, and Y-axis will be the fraction of molecules with a given speed. Okay. Fraction of molecule with a given speed. Okay. Fraction of molecule with a given speed. These things. Now, this curve is known as Maxwell distribution curve. And what are the important feature of this curve? Now we have to learn. If you see this portion and this portion. Okay, so the fraction of molecules with very low speed and very high speed is very small. Yes or no? The fraction of molecules are here very low speed, and here the fraction of molecules have very high molecular speed. Their number is quite small. Okay, their number is quite small. And the second feature is the fraction of molecule possessing higher and higher speed. So goes on increasing. See this one. The fraction of molecule having higher and higher speed, it goes on increasing. It reaches to a peak. After that, it again become decreasing. Okay, it's become decreasing. So fraction of molecules are having higher speed. It's become reached. It has become higher and higher. Then it is reached to a peak. Then it is goes decreasing again. And the next important thing is that the maximum fraction of molecule possesses a speed, okay, corresponding to the peak of the curve. The speed corresponding to the peak of the curve is known as most probable speed. So this portion, okay, this is, if we consider this one, so here the fraction of molecule will occupy the most probable speed. Okay, the highest number of molecule will have now most probable speed. Okay, this peak represent that. So it is known as most probable speed. It is known as most probable speed. Okay, most probable speed, and it is UMP. Okay, it has been showed by a very UMP. This is the most probable speed. What is the most probable speed? Okay, most probable speed means, what is the definition for most probable speed actually? Okay, so most probable speed in case of gaseous molecule, obviously, the speed which is processed by maximum fraction of gas. Okay, so UMP means what? UMP, most probable speed, means the speed, okay, the speed possessed by maximum fraction of gas. Okay, maximum gas from maximum fraction of gas molecule, obviously. Okay, at a given temperature. Temperature will be constant that time. Understood? So what is most probable speed? The speed processed by the maximum fraction of gas molecule at a given temperature. And this is according to the peak, when the maximum fraction of molecule will have the speed, this one, that is known as most probable speed. Understand? Understand the concept or not? Yes, boys, please let me know.
Miss, your voice is coming low.
Yeah, understand the concept or not?
Yes, miss.
Okay, now next. So there is an interesting fact. That fact is that the distribution of speeds, okay, the distribution of speed at a particular temperature also depend upon the mass of the molecule. Okay, so it is also depend on the mass of the molecule. Okay, that means at same temperature, gas molecule with heavier mass, okay, gas molecule with heavier mass have lower speed. Okay, so if mass is heavy, speed will be low. If mass is, sorry, if mass is heavy, okay, speed will be low. And if mass is lighter, speed high. Okay, let's see with the help of a graph. See the fraction of molecule. This one is fraction of molecule with its given speed. Okay, and here, according to the x-axis, will be that molecular speed. So if we draw the curve, see, for two molecules, nitrogen and chlorine, okay, so this is for, if I consider, this is for UMP for chlorine, and this is for UMP for nitrogen. So who have higher speed? Obviously nitrogen. This is the molecular speed. If I consider this is 2, 4, 6, 8, 10, 12. So obviously the molecular speed of nitrogen is higher because nitrogen is lighter. What is the mass of chlorine? Mass of one chlorine atom has 37.5, whereas one nitrogen atom, what is the mass for one nitrogen atom? Mass for one nitrogen atom is 14. Yes or no?
Yes, miss.
So obviously for that, we can say that if a gaseous molecule with lighter mass will have the higher speed and the gaseous molecule with heavier mass will have the low molecular speed. So this is the effect of mass of the molecule. Now, next topic will be effect of temperature on the distribution of speed. Okay. Next to the effect of temperature. Okay, effect of temperature on distribution of speed. So what we know that if we increase the temperature of any substance, the kinetic energy of the substance will increase. So obviously molecular speed will also increase. In case of gaseous substance, if we increase the temperature, the kinetic energy will increase, the randomness will increase. So if randomness increase, kinetic energy is increased, obviously molecular speed will also be increased. It have to be increased. Okay, and obviously when molecular speed increase, okay, the value of most probable speed, that is UMP, increase with increase in temperature. Obviously, this is a fact. Okay, And if we draw the curve, you can see that the total distribution curve will be flattened. Okay, so this is this side fraction of molecule with this given speed, this side. Fraction of molecule with a given speed, this side, and this side is molecular speed. Okay, this side is molecular speed. Now, this is for temperature T1. Okay, and this is for temperature T2. This is for temperature T1. This is the most probable speed UMP for temperature T1, and this is UMP for temperature T2. So obviously T2 is greater than T1. Okay, so that means when temperature increases, you can see the molecular speed is also increases. Okay, so the curve broadens at the high temperature. So if we consider this side, this is the molecular speed for temperature 1. This is the peak comes in temperature 2. That means when temperature increases, okay, the curve broadens at high temperature, as you can see in the curve. So what we can conclude it from that if temperature increases, molecular speed increases, and most probable speed also increases. Clear? From this curve we can understand easily. Yes or no, boys?
Yes, miss.
Okay. Now, next we have to learn few things. Next we have to learn few things. That is, just like number 1 is UMP. That is most probable speed. So what is most probable speed? I have already discussed. I'm just going discuss it again. It is the speed processed by the maximum fraction of molecules of gas. Okay, this one. See, what is most probable speed? It is the speed processed by maximum fraction of molecule. Okay, this is a speed processed by maximum fraction of molecule of gas at a particular temperature. Okay, now, so it is the speed processed by maximum fraction of molecule of a gas at a particular temperature. Now, next is average speed. What is average speed? Let's see what is average speed. Okay, let's see what is average speed. Suppose there are n number of molecules. There are n number of molecules in a given sample of gas. Okay, and and their individual speeds are like U1, U2, U3, UN. So what will be their average speed? That is UAV, that is average speed will be what? U1 plus U2 plus U3, UN. Yes or no? If n number of molecules are present in a given sample of gas and their individual speeds are like U1, U2, and U3, so obviously their average speed will be the speed, total speed of the molecules divided by the number of molecules. This is the average speed. And alternative methods are also there. Suppose E1, okay, is the speed of molecule N1. Suppose U1 is the speed of molecule N1, U2 is the speed of molecule N2, and U3 is the speed of molecule N3. So like this, UN is the speed of molecule NN. So what we can say that average molecular speed will be what? Will be what? N1 U1 plus N2 U2 plus N3 U3 divided by N1 plus N2 plus N3. Yes or no?
Yes, miss.
Okay. So these are the things you have to remember. I will upload the PDF in Google Classroom. So obviously you will write down those formula in your copy. Very much important. Now next topic will be next like this one is suppose root mean square speed. Okay. RMS. Root mean square speed. Okay. Root mean square speed. So root mean square is what? It is the square root of the mean of squares of different speeds of the molecule of a gas. Okay, so if U1, U2, U3, okay, U1, U2, U3 are the individual speed, at the individual speed of n molecules, at the individual speed of n molecules, then we can say that RMS, okay, URMS is equals to, that is U1 square plus U2 square plus U3 square divided by n. Okay, and alternatively we can say that if U1 is the speed of molecule N1, U2 is the speed of molecule U2 is the speed of the molecule N2, U3 is the speed of the molecule N3. Okay, then RMS is equals to N1 U1 square plus N2 U2 square plus N3 U3 square divided by N1 plus N2 plus N3. Okay, N1 plus N2 plus N3. Clear?
Yes, miss.
Okay. So this is the, we have learned what? We have learned most probable speed, UMP, most probable speed. We have learned average speed today also. And we have learned root mean square speed, that is RMS. So if we draw a graph, we can understand what are the speeds like this. So let's draw the graph. If this is the graph, okay, sorry. If this is the graph, and here the fraction of molecule, here is the fraction of molecules, and here is the molecular speed. Here is the molecular speed. Just a second. So here is the molecular speed. Okay, here is this molecular speed. Then this is the peak is the most probable speed of the molecule. Okay, this will be the average speed. This will be the average speed, and this will be RMS. Okay, this will be RMS, that is root mean square speed. And what is the relationship between this most probable speed, average speed, and RMS? So the relation is like this: RMS is greater than average speed, is greater than most probable speed. From the graph, we can understand the value of RMS is high, then the value of average speed, then the value of most probable speed. Yes or no?
Yes, miss.
So, have you all understood?
Yes, miss.